Yeah, so hi everyone. My name's John. And today we're going to go through some of the TikZ library. But just be aware that I'm not really an expert in this. I've just kind of forced myself to use it enough to get comfortable with it, and I'm here to share some of the basic stuff that I've picked up. This means that I probably don't code with like the absolute best practices possible, and you can probably find quicker, shorter, and better ways of doing some of the things that I'll show you today, which I would definitely encourage. So this tutorial is not supposed to give you like a comprehensive introduction to TikZ. It's just supposed to show you enough so that you can start exploring the capabilities of TikZ and the ways that you may use it for your own reasons. For example, one of the things that we won't talk about today are TikZ libraries. So they're useful extra packages that you can import, and they have a slightly different syntax to the use package. I think you do like /TikZ library, and then you pass the name of the library to import it. But they basically just do what I guess you would call like TikZ subroutines. So, they automate a lot of kind of nice things for specific purposes. So I use one called Quantix because it helps me to draw. Sorry, I haven't got any of this on the screen. I'm just giving you guys a little bit of a flavor intro. But yeah, I use one of the TikZ libraries called Quantix because it gives you a really easy way of drawing quantum circuits, which are a big part of my research. But I've also used others like TikZ, which lets you draw commutative diagrams pretty easily, and a fun one called TikZ People, which lets you draw little customizable avatars and people in your graphics. Anyway, today we're just going to go through some of the code, and I'll explain the syntax and show you some small changes and little things that you can tinker with. And I'm happy to take questions at any point, but preferably only on parts that we're up to or things that we've already covered. And if I'm going too slow or too fast, then just let me know. And I would encourage you all to, I don't know, take notes or maybe write some more comments in the file for yourself. So to take part in today's tutorial, I was told that everyone would have an Overleaf account. So you're going to have to, and hopefully has everyone been sent that zip file?
Yeah, I have uploaded it on that link online and broadcasting this kind of chat.
Okay, great. Yeah, so everyone will have to download that zip file, uncompress it, and then make a new Overleaf project and basically just copy all the files from that uncompressed zip file into the Overleaf project. So it'll look something like this, right? You have, I don't know, I just called my project TikZ demo, and then you'll have these 3 exercise PDFs, this MNIST sample, the star rating, and this TikZ tutorial tech file. Yeah, so if that's clear, maybe I'll just wait for a minute in case can anybody just tell me if they have or haven't done this? Have you?
Yeah, like a zip file, and just launching.
Okay.
I believe you can just zip file it together.
You probably can. I just don't know how to do that. Oh, okay, great. So maybe I'll just show you from here. Once you've logged into Overleaf, it'll look something like this, and then you just click New Project, and then it'll give you an empty project, and then you can just copy all the files by dragging and dropping them onto this part of the interface, or there are other ways as well, apparently. Yeah, so I'll just wait for like 1 minute and then we can push on. So yeah, for you that just came, you might not have heard, but have you seen the zip file for this tutorial? Oh, that they've already done it? Okay, great. What about in the room? I'll wait for you guys to get it done, and maybe then that'll be enough time for the online people as well. So just log into Overleaf, make a new project, and then put the files from that uncompressed zip file into the project. Hey, Nick. So did you see the zip file that you're supposed to, you're here for the TikZ tutorial, right? Yeah. So there's a file that you have to download. Is it just in the chat, or it's been uploaded elsewhere too, right? Yeah. Okay, so yeah, Nick, all you need to do is just uncompress the file and then make a new project on Overleaf and drag and drop the files into the project. Um, cool. What about you guys? Have you done that? Yep. All right. Well, yeah, if you have any troubles with that, Nick or other fella, sorry, then just let me know. Okay, so yeah, if you just open, like, click on the tixtutorial.txt file and then click recompile, hopefully what you'll get is a document that looks like this. And I'm pretty sure that I gave you all of the files that you need. So this is basically going to be our main focus today. I might even just get rid of this part. All right, so I just wrote a little intro. TikZ is a powerful and flexible package for creating high quality graphics that can be used either within LaTeX documents or to produce nice PDF files using the document class standalone. You can see here that we're using document class article. And while other graphics packages may offer drag and drop interfaces, TikZ is entirely code-based, meaning that you very manually define the objects and relationships through commands, which gives you an exceptional level of control and customization. And its vast range of tools and libraries make it suitable for anything from simple geometric illustrations to more sophisticated flowcharts and diagrams. It can also be used for data visualization, but we won't cover that here. And I'd personally recommend doing it in something like Matplotlib anyway. Now, TikZ may initially feel like it has a steep learning curve, but once you get used to some of the syntax, I think it becomes quite natural. And in my opinion, the level of control that TikZ provides justifies the initial learning curve. Now, this file contains a collection of examples and exercises showing you how to use the basic features of TikZ to draw and customize shapes, diagrams, and text in various ways. Specifically, we'll demonstrate and use two basic but very useful TikZ commands. So I'll zoom in just a little bit. A little skeleton diagram showing you how to pass things to this. So when you call draw, you need to supply options, and draw is, sorry, you need to supply commands, but you don't need to supply options. And draw is used for creating and customizing simple geometric shapes like lines, circles, and polygons, or more complex paths using a combination of coordinates and drawing options. And then the other one is node. So this one is used to place text such as labels or annotations inside various shapes like circles or rectangles at given coordinates or relative positions in a diagram. So yeah, if some of that doesn't make sense, I'm sure it will become a lot clearer later. So yeah, like I said, supplying options for draw is optional, and supplying both options and a label for node are both optional too. So, I mean, I guess technically with node, you also don't really need to give this thing any text, but if you don't, then the position you specify isn't going to have anything annotated there. It'll just be like that, you know, LaTeX has allocated some memory to specify that there is like some position of note there, but it won't actually print anything. So more useful information about these libraries and options can be in TikZ can be found at the link here, as well as in a plethora of other useful online resources like YouTube videos, Text Stack Exchange, and of course ChatGPT and other LLMs. So yeah, we just got a contents page here. So I'm just going to kind of go through the code for these examples here. And then I've just got some closing remarks. And then if we have time, which hopefully we will, we'll do some of the exercises. And after the tutorial, I can send you guys solutions if you want them. Okay, so let's start with, yeah, so I'm not sure if everyone's used Overleaf before. Hopefully you have, but one of the nice things is that once you've compiled, you can just double click a spot in the code and it'll take you to that part in the left interface. So yeah, you can see here is the section of examples. So this is the first example. Might even try make it like, yeah, if for people online, just let me know if it's too small or anything, but hopefully it'll be fine. So the first, I've used subsections for the examples within that section. Yeah, for you that just came, did you have any questions quickly? Oh, okay. Because yeah, if you've got a device here, then you can make an Overleaf project and copy the files in and kind of like walk through it with us rather than just having to watch me scroll. You can, you know, kind of go at your own pace through it. Okay, so I'll get started. Yeah, if you want me to help you catch up, then that's more than fine too, but just let me know. So yeah, I've decided to put all of my TikZ pictures. So here, this is what you do to start using TikZ. You need to put a begin TikZ picture and then later an end TikZ picture, and then you can write all of your stuff inside. It doesn't actually need to be indented, but it obviously just makes it much more readable. But I've decided to put all of my TikZ pictures. Oh yeah, is there a question online?
Yeah, that's okay, mate. Sorry.
Yep, no worries.
So when I do diagrams and stuff, I use a lot of like dot and mermaid diagrams and whatnot. Is this as popular as those, especially in a research context?
My honest response to that question is that I've never heard of those other ones that you mentioned, so I'm not
Oh,
really sure.
wow. Okay, well that's fair
Yeah.
enough. Yeah, I suppose this would be standard then. I imagine.
Yeah, I mean, I think that a lot of the professors at UW use this to draw, especially in math, use TikZ to draw some of their more like complicated stuff. But I think if you're only doing relatively simple stuff and maybe you don't, worry that much about the quality of the image, then you can probably do things a lot easier than using TikZ. Yeah, like I was saying at the start, I think this is a very manual graphics library. And I think that the
Yeah.
way that you specify things is not very user friendly, but it does give you a lot of control. So I think this would be a good option for you if you have like really finicky stuff that you want to draw with really high quality graphics, then I think TikZ is a good option. But
Yeah, I'll need
if
that
you
then.
yeah. Yeah. So sorry, that's the best answer I've got to your question.
No, that's very helpful. Thank you. I'll definitely invest some time into looking at it now as well.
Cool. Okay, thanks. Yeah, if anyone else online has a question, I think if you click the raise your hand icon, then it lets me know that someone's trying to ask something as well. Okay, so yeah, like I was saying, this is the environment. Maybe I should talk about even earlier on. To make sure that you're able to use TikZ, you need to have this use package TikZ in your preamble. And when I say preamble, that's everything that comes before begin document. So you can see here that I've imported a handful of packages just to do like really specific things. And I like to just leave a comment after the use package import to let me know why I even imported that, because I'm sure you're seeing a lot of LaTeX kind of templates that sometimes there'll be like 50 packages just imported and like you don't really know what half of them are for, especially if you like import them from some Stack Exchange article or something. So yeah, I like to comment mine, but you need to have the use package TikZ to begin a TikZ picture. So yeah, this is the main environment, but I decided to put it inside a figure because if you import that package above and use this option capital H, then you can force the placement of the figure where you want it. Whereas like sometimes if you just had figure without the H, then your figure is just like LaTeX just does this optimization thing and puts your stuff where it thinks it looks pretty. And sometimes that's not where you want it. But I wanted it to be under this subsection heading. So I used this H option. Then I center it with centering. And then the first thing that we do is turn on the help lines. So this basically shows us a grid of 2D points and you specify the, one corner of the grid and the other corner of the grid. And this just gives you this really like, at least if you pass dotted to the draw, then you get this really subtle grid here. If we got rid of dotted, then it becomes a lot more apparent. But I think this is good practice just because, you can turn the help lines off by just changing. Yeah, so I'm not sure why it doesn't like that. Oh, sorry, it should be help lines. I'm just going to put the dotted back in. You can kind of see what it's done here. So you can turn the help lines off by just passing white. Oh, sorry. By just passing in white here. And then that just basically prints the help lines, but in white, so you don't see them. But the reason I like doing this is because it gives you kind of like a fixed canvas. And you can see that, these really are just, sorry, I need to get rid of the white. So this basically just tells you like where all of the relative locations with respect to your picture are. So it just gives you a feel for where you are. Whereas if you just start putting putting an object at some random spot, you can kind of like work with respect to those coordinates, but this gives you basically a pair of axes. Okay, so the first thing I did was label the origin just to let us know kind of where we are. And I think this is a good thing to do at any point if you kind of get lost in your own syntax, because sometimes you just end up with like, you know, at least I do when I'm like really adjusting fine details of a picture. Sometimes I'll adjust the coordinates by like 0.01 or something. And then it's just hard to get intuition for like where you are. So sometimes just putting a node at 0, 0 and putting the label as 0, 0 gives you an idea of where you are. Okay, so then I also labeled, yeah. Yeah, I guess I could put negatives here, and then this would be the top right corner.
Oh.
Yeah, well, the coordinates are kind of only really defined within the TikZ picture. So the only thing that's fixed is that going to the right is an increase in the x coordinate, and going up is an increase in the y coordinate. But if you want 0, 0 to be at the top, then you could just put it up there and then pick the other corner of the grid to be somewhere below. Or I'm pretty sure that you can pass y scale equals -1 as an option to the TikZ picture. And then that would be like y is going in the downwards direction. Yeah, you might have to try that. I'm not 100% sure that's the right option, but I know that this would work if you passed it to something like draw. But yeah, that's a good question. So yeah, you can kind of like flip which way an increase in y would be tracked by passing this y scale or equivalently x scale as an option to the begin TikZ picture. So yeah, that's hopefully all clear. And so there's a few different ways of specifying coordinates in TikZ. So maybe I'll just explain it. This here, node at 0, 0, just basically says like define something at 0, 0 and then label it with this text here. So you can put basically whatever latex text that you want in there. But notice how from this syntax, we haven't actually given it like a reference, like a label for, so later on we'll see that you can put something here that says like label, and then you can refer to the position of this node by, rather than having to use Cartesian coordinates, you can just write round brackets with label in the middle, and it'll kind of automatically know where you're referring to. But we did have to do node at coordinates and then the text, but the options in the label we haven't passed here. So we can also specify things. So yeah, the first one, I guess we've already kind of seen it, but the first one is Cartesian coordinates, right? So this draw command here just says draw a straight thin black line from the point 0, 0 to the point 0, 5. And you always want to have this semicolon at the end of your commands to kind of let LaTeX know that this command is finished. And then I just put a node at the end of this line and put Cartesian there to label it so that we know which line has been produced by this part of the code. So we can also use relative coordinates now. So this command is almost the same as this one, and it does exactly the same thing. But basically what we've said here is that where we want to draw the line is from 0, 0 to wherever we just were, but plus 5 units in the x direction. Sorry. Yeah, 5 units in the x direction and 0 units in the y direction to get this line here. So yeah, I'm wrong. They don't do exactly the same thing. This one puts a line along the y-axis, and this one puts a line along the x-axis. And then I just labeled it as relative Cartesian. So then you can also specify things using polar coordinates, and you pass the position using this syntax. So you put the angle in degrees at the start, and then you put the length of the circle, the radius, after the full colon. So this is just saying draw a line from 0, 0 to basically 5 times cos of 60 and 5 times sine of 60 in degrees. So that's this one here, right? So this is a 60-degree angle here. It's just starting from the positive x-axis, rotating anti-clockwise, It says go 60 degrees and then draw a line of length 5, essentially. But this coordinate is just a reference to this point up here. And then you can do the same thing as the relative Cartesian coordinates, but you can use relative polar coordinates, right? So I think this will even work if we put that there. And this basically just says draw a line from 0, 0 to wherever we just were, but plus 5 times cos of 30, 5 times sine of 30. So you guys familiar with that? So like polar coordinates, you have theta and you have r, and then the corresponding Cartesian coordinates is r cos theta in the x position and r sine theta in the y position. So that's just how to think about converting between the two. Yeah.
From the
Say that again, sorry.
So if you do two relative polars, like a 30 column 5 and then 30 column 5 again, does it
You mean like that?
with another dash dash there, like a second line?
Oh, right. No, it doesn't. It'll just do another. This would be a straight line.
Okay.
Not like a 30 and then another. Yeah. So it's not. It's just relative to like the fixed XY axes on your page, not relative to whatever angle, because like if you, it's a good question, but this will be a straight line. 30 degrees will always be in the same direction. Let me just typeset that to make sure that it actually works like that, because I'm used to putting like dash dash space plus plus. Yeah, okay, it looks like that's worked. So yeah, there are the different ways that we have of passing coordinates to TikZ. So I'm gonna go maybe a little bit faster. I didn't realize that we would be taking this long, but this is the second exercise now, and this is just drawing some shapes. So the same thing as before, we force the figure to be here, we center the figure, and then we begin the TikZ picture. And remember that at the end, we need to end the TikZ picture. And I've just put some stuff here to basically, I don't even think I used these labels in the end, or maybe I did for some of them. But yeah, this is basically just end the TikZ picture environment, then label the figure, put a caption for the figure, and then end the figure environment and start a new page. Okay, so we'll go through this now. So this is the picture that we produced, and I labeled them here by when I was drawing the particular one. So all of this stuff here is basically just at each of these spots here, 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 and here, and here, and here, and here. I just wrote in the coordinates, and then I added the vector 0.1 minus 0.1 to all of these points, right? I did it very manually. And that's basically just to shift these numbers a little bit in this direction, so they're kind of like within this 2x2 box. So that's all that was. This part of the code is just specifying the positions of all of these numbers and then putting the numbers there. Okay, so in the first one, we just drew a line. We've already seen this, right? We just specify the first spot, which is here, and then draw a straight line to the second spot, which is here. And now we can draw a triangle using relative Cartesian coordinates. So we start at 3, 6, and then we want to move to wherever we just were. Oh, I've done the different syntax here. Clearly it both works though. They both work, so maybe it doesn't need to be changed. But yeah, it says go from wherever we were and then add the vector to 0 and then draw a line to that spot. So that's the bottom line. And then we do the same thing, but we shift by the vector 0, 2 to go up, and then we do dash dash cycle, and that takes us back to wherever we started. And then we put the semicolon to end. So now I'm going to draw a circle. So these are all pretty standard, like I'm sure you guys could remember this, but there's also a bunch of built-in things that you can use, like circle and rectangle and some other stuff that we'll go through. And here's our first kind of appearance of one of those functions. So this big mess here basically just says at the point, this is in polar coordinates because we've got the colon here, and it says at the 45-degree angle from the origin, which is down here, and 7 times the square root of 2. So basically all I'm trying to do is specify this point here in the middle of the circle, and that's 7 in the coordinates for this point are 7, 7. So the length of the vector that points to that spot is 7 times root 2, right? Which is like from Pythagoras. And then it says at this point, draw a circle which is centered at that point of radius 1 centimeter. And then we get this circle here. So now we've got another one, this rectangle. So this is just specify one of the corners, specify the other corner, and then this function basically just draws two kind of straight lines between those points that only go horizontally or vertically, and you get this rectangle. From memory, I think I specified this point and this point. Okay, so now we'll see so far in the draw, we've only really used this dash dash, but there's others as well. So for example, this vertical line and then a straight line means that the line connecting the ends of the arc will go, yeah, so I've actually done two things here. I started at the position 5, 4, and then we draw some arc of a circle. So the position 5, 4 is here, and then all I specified was where the arc should start, where the arc should end, and the radius of the arc. So this is just like part of a circle, right? And we went from 0 degrees to 270 degrees. So it's going to draw like 3/4 of a circle in the anti-clockwise direction. And then this part here, so remember at the end, we've got this cycle. So from this point, because I put cycle here, in some way, TikZ is going to join the start point and the end point of the shape that we just drew. But this, by putting this here instead of the dash dash, what happens is that the TikZ knows to first draw like a vertical line up to whatever, in line with the point that we're going to end at, and then a straight line. So it's like vertical first and then horizontal. But we could, switch it to the other side. And this will now draw the horizontal line first and then the vertical line. Or if we just get rid of it and just leave it as dash dash, then it draws a straight line. So, like you could use this to really conveniently draw a rectangle too. You could just like, we probably could replace this with something like I'm pretty sure that will draw the same thing. Yep, so we just used this twice. It says from this point, draw a straight line and then a vertical line to this point, and then draw another straight line and a vertical to the point that we started at. So now we see another built-in function, ellipse. So this one just says centered at this point, draw an ellipse whose horizontal axis is 1 centimeter long and then whose vertical axis is 0.5 centimeters long. And that gives us this here. And then this is where things get a little bit funky. So now we're going to draw the pentagon. And the idea here is that we want to shift the point 1, 1. So remember that in this little block here, the origin's here. So this point is 1, 1. And basically all we're doing is like parameterizing a circle and incrementing the argument of the circle by fifths of 360, right? So we're going to start at the top and then add a fifth of 360 and then pick that point and then add a fifth of 360 and pick that point and so on and so on. And you can kind of see that I started, so we got 1, 1 in all of them. Yeah, I need to make this a bit wider, I think, to make it more obvious. So we've got, this is the first point. And every time that you use cos or sine, you need to put these curly brackets around the expression. Otherwise, it's just going to be like, what the hell is this that you've given me? You can do things like plus, times, divide, take without the curly brackets, but to use the kind of other functions like cos and sine, and there's probably others, you need to have the curly brackets. Okay, so you can see that I've got the point 1, 1 in all of them, and then here I've added just cos of 90, and here I've added just sine of 90. So you know how you can parameterize a circle starting from the right side in the anti-clockwise direction with cos theta, sine theta? Is this familiar to everyone? I see Nick nodding, but does everyone else get what I've done here? Okay, so this is, maybe I can, I'm not sure exactly how to draw it. I guess I could draw it and just turn on the camera. Do you know if there's a pen in here? Oh, okay. Yeah, maybe not. Anyway, all we did was start at this point. That's why there's the 1, 1. in all of these, like there's one in the y coordinates and one in the x coordinates. And then I want the parameterized circle to start at the top. And that's 90 degrees from this positive x-axis in the anti-clockwise direction, right? So that's why there's the 90 here, because that's where I want it. That's where all of these 90s are here, because I want the parameterized circle to start at the top. And then all I've done is go through and said, okay, now we add 0 lots of 300, 0 fifths of 360, then 1/5, then 2/5, then 3/5, then 4/5, and then cycle back to the start. So that's what this code does. The idea is that we want to be centered here, and then we add to this point a parameterized circle that starts pointing straight up and then goes anti-clockwise in increments of 1/5 of 360, because we want 5 sides. Okay, well, if there's any questions about that, please feel free to ask. All right, I'll just push on. If you want to raise your hand and ask me at another time, that's fine too. Okay, well, hopefully this one will sink in, because this one's a little bit more complicated. So now we're drawing the star, and we want the star to be centered at the point 4, 1, which is just here. So all I did was start at the top again. So, we've got the point 4, 1, and then we're adding the parameterization of a circle to this point. So we want the point to start at the top. So we go to this 4, 1, and then we add like the top point of a circle here. So that's why we've got the cos of 90 and the sine of 90. There's 0 here. So currently this is just 4 plus cos of 90 and 1 plus sine of 90. And then we do the same thing as before, but we're incrementing in tenths of 360 now. It's because there's 10 points, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we go back to the start. And all I did was the same thing as, so, if I got rid of the 0.5s here, then this would just be a 10-sided shape. But what I'm doing here is kind of manually sampling every second point from a circle of half the radius. So that's why we, these 5 points lie on a circle, and these 5 points lie on a circle. And by just alternating between picking from the circle of radius 1 and picking from the circle of radius 0.5, we can draw this star here. So I hope that makes sense. If not, please feel free to ask questions. What do you mean? To just generally pass a few parameters to, and then it'll just automatically, yeah, you probably could. I don't know how to do that though. It probably would be good for that, yeah. And I think on the next part, when I've styled the shapes, I did say like most of this can probably be done with a loop as well. There's 4 each in LaTeX. I don't know much about the macros though. Okay, and then the shape 9 is just to plot the curve cos cubed of t, sine cubed of t for t from 0 up to 2 pi, but LaTeX works in degrees by default, so we need to go from 0 up to 360. So we specify here that the domain is 0 up to 360. We want to take 100 samples of the curve, and then we want to smooth them in some way. And we'll use our variable as t, and we want to center this whole plot at the point 7, 1. So the first sample is just going to be cos of 0, sine of 0, which is here. And then it's going to go through and it'll sample 25 points here, 25 points here, 25 points here, 25 points here. And then it'll join them up and smooth them out. So this is useful because it lets you basically draw any curve that you can parameterize, as long as you're, willing to give it enough samples, then that helps you to draw things. So you can tell here that everything is just black and white. So on the next example, I've showed how to introduce some kind of much more custom formatting. So here I included an example showing you how to produce the labels. Yeah, I'm not going to talk about the help lines every time, but you can see here that we've drawn a grid from 0, 0 to 8, 8. So what this section of the code does is produce these labels in a loop. And I thought I would just include this here because I'm not sure if there's another one, or maybe there is, but this is how you write a loop. So this variable x, which you have to reference with the backslash, and then you define the range of values that you want it to take, and then you have the code between these two curly brackets will get executed for each value of x in this set here. And I just did it x and y so that I could draw the grids. I'm not going to bother going through this, but this is just me writing down a formula that specifies these points as we go through the x and the y's. Okay, so now we see our first draw with some options. So we've done exactly the same line as before. We just drew a line from 0,6 to 2,8, but now we've made it blue and thick, and we've given it an arrowhead on the second point that we went to. So if we change that to this side, then the arrowhead will change side as well. And then in the second one, we've drawn the same triangle with the relative Cartesian coordinates, but this time we made it red and we drew the line in a dashed format, and we've increased the thickness even more. So this is pretty much all just the same code, but I've showed you how to use a variety of different options. So here we've given the circle a fill of yellow, and we just made the barrier or the line that got drawn ultra thick. So I thought I'd just say quickly that this draw, even if you don't close up your shape and you call fill, it will just draw a straight line between the endpoints and then fill that area. So you don't need to draw something closed with draw to give it a fill. Like for example, before we drew this part of the circle here, if we just had this 270-degree arc and we filled it, then it would draw a straight line here and fill that area with whatever we specified here. Okay, so now the rectangle, we gave it rounded corners, and we filled it with a color that is 50% red, and then 100 take whatever we specified here worth of the other color. So if you put like 90 here, then it would be 90% red and 10% blue. And then we can also manually adjust the line thickness here. So this is just kind of me showing you like there's thick and then very thick and then ultra thick and then custom thickness. So I just made the circle dotted and thick, but I didn't really do anything else to it. And then here's another option that we could pass, which is rotate 45 degrees about this point. So this kind of looks like Cartesian coordinates, but I think it's not. It's just like how far do we want to rotate, and this is anti-clockwise too, and about which point are we rotating. So that just rotated this ellipse here 45 degrees anti-clockwise about the point that it's centered at. And now in this draw we've got some X direction scaling and some fill opacity. Yeah, okay, so this is something that I wanted to show. So you can see that this X scale equals 0.6 in the draw. All that's done is take all of the X coordinates which were specified inside of this draw and multiplied them by 0.6, which has squished this pentagon in this direction. But it won't be relative to any boundaries, it's relative to the origin. So the only reason that this thing didn't get completely shifted is because it's pretty much like right next to the origin. If we did this to, say, the ellipse, now you can see that it got moved because the points that specify this ellipse have, you know, X values of like 7 or something, and then they got multiplied by half, which brought it roughly down to 3.5. And then this fill opacity just tells you, like, you know, how translucent or how see-through do you want the fill of this shape to be? And here we just said 0.25. Then for the next one, we squashed it in the Y direction, but again, remember that the origin is here. So if we did it to something like the triangle, then it would have got shifted halfway down the image. And we've got this draw opacity. So this one's a little bit harder to see. I'll show you here. Yeah, so this kind of shows you why TikZ is nice, because you can zoom really far in and things don't get pixelated. But you can see that the actual boundary of this star is now quite translucent, whereas before we left the boundary, the same, so we can't see through it, but we can see through the fill. So you can customize both of those independently. And then for the plotted one here, we did it for both. Yeah, I thought it would let me zoom in a bit further than this. But we made both the boundary and the fill to have little opacity so that you can see through it. And I didn't really change anything about how the coordinates were specified here. But yeah, note 7 and 8, which are these two, can probably be produced with a loop, but instead I just copied and pasted one line and manually changed the increment of the argument in the trig functions. There's probably a better way. And yeah, we spoke about here, to change both, you just do opacity. So to do the opacity of the boundary, you use draw opacity. To do opacity of the whole thing, you just use opacity. And to do the opacity of the fill, you use fill opacity. Let's move on to the next one. Oh. Root node, and this is the first time that we've seen a node with a label, in this case start. Also note that we're using node to produce both text and a shape by passing the draw option to node here. So there's a few different ways that you can choose between how to both draw a shape and then label it with some text, and I'll talk about that at the end, but for now I'm just going to kind of show you. So we can see that at the node that we produce, where we previously only used nodes to put little labels on something, you can actually use it to draw a shape around the label as well. So here the start just has a scaled square around it. And by scaled, I just mean like it kind of just tightly fits the text within it. And we've given it the label start. Then we did, I kind of just manually specified these other ones. So this is just a tree diagram illustrating the possible outcomes of two coin flips. So the first coin flip either gives us heads or tails, and then the second one gives us heads or tails, heads or tails. And I've just labeled the nodes with the associated outcomes. And then I've also given them, so the text that gets typesetted on the image is the stuff in the curly brackets at the end, and the label of the node, which we can use to refer to it, is given in the round brackets just after the options. So yeah, I just drew everything kind of exactly as you would expected. And then here, this is nice because if you do things like this, where you use the node to both draw the shape and to produce the text, then you can draw lines between them by just passing the labels, connected by these dashes to draw, rather than having to explicitly specify the coordinates here. And now I'll show you, now I'll show you some ways of styling. So it's probably pretty familiar to you at this point, but maybe one thing is like how to get the lines looking like straight and then all of that. So now so what I wrote here was, now we're going to draw the first layer, but note that the fill equals black 5. So this is exactly the same thing as fill equals, exclamation 5, exclamation white. So if you don't specify a second color, it just automatically chooses it as white. And all we did to resize the shape of the nodes here was to increase the font size. So here they're pretty small, right? But then here we've increased the font size, which has automatically let node resize the drawn rectangle around the text. And we gave it rounded corners and we made it ultra thick. And then we filled it with something that's 5% black and 95% white. Now this is for the second layer, so I'm pretty sure I gave them all exactly the same options, but you can see that I made the color of the text of the H red and the color of the text of the T blue. And then I just did exactly the same thing here. So same options, but now we've got H's and T's sometimes in both. So that's for this node here. Okay, but remember before when we drew the lines and we just did the node labels dash dash another node label. Sometimes you want to be able to customize that a little bit further. Number 5. So this is where, this is where we're up to. Now we're going to draw the edges from the first to the second layer. And this is the first time that we've seen the label of a node be followed by a dot and then some angle here. So I've just got some options in the draw here. So, make this line have rounded corners, make it very thick, make it red. And then what I want you to do is exiting the shape that you've drawn for this node start at an angle of 250 degrees. So you can see here, if I get rid of this, so what was it, 250 and 290? If I get rid of them, then they both just get connected to start at the same point. And we don't want that. We want to separate them a bit. So we tell this one to exit at an angle of 250 degrees, and we tell this one to exit at an angle of 290 degrees, which is just 20% below, 20 degrees below 270 degrees and 20 degrees above 270 degrees. And then what I said was that after you exit the start at that angle, I want you to draw a vertical line and then a straight line to the point -2, -2, which from memory is there, right? So it draws a straight line and then a vertical line and then a horizontal line to the point -2, -2, and then it draws a straight line, a horizontal line and a vertical line to the node. So that's how you can get your lines to look like this, and you can probably see that this makes it very customizable, right? Because you could just tell it to visit some random point before it goes to the node, and you can specify all these custom ways that you want the line to look. But I thought that the main thing to remember here is that sometimes one of the annoying parts about using this kind of like automated labeling of nodes to draw lines is that sometimes the lines will be drawn to the same part of the node. And you don't really want that, especially in things like tree diagrams. So this is just me showing you how you can change the angle that the line being drawn exits from the shape that was drawn by the node. Now we'll go on to the next example. Yeah, so now we get to probably some funkier stuff. But if you could have digested everything we spoke about already, then I'm pretty sure that you can do this too. So all I did here was basically specify a whole bunch of points that I want my input nodes or my input neurons to appear at. And then I labeled them with X1, X2, X3, put some vertical dots here, and then put XN at the bottom. So that's before, like there's no lines drawn yet. And I've labeled them in a kind of understandable way, right? This is input neuron 1, input neuron 2, input neuron 3, and then input neuron N. And then I did the same thing for the first hidden layer. And I've just, given them all the same X coordinate so that they're arranged along this line. Similarly, the same X coordinate. And then for the second hidden layer, same X coordinate. And then for the output layer, same X coordinate. And then all I did was adjust the Y coordinate to arrange them in a way that I thought looked good. And then, I've got the V dots at different points. So then this I'm sure you can do with a loop somehow, but I haven't figured it out because passing like -X in here is really finicky. But yeah, basically all I did was just copy and paste. I wrote out one of the lines, copied and pasted it however many times I needed, and then go through and change them just like. So it's very manual, and I'm sure there's better ways that you can do this. But there is a few things that we don't really like about this, and one of them, you can probably do most of this with a loop, but this does have the disadvantage of not allowing you as much unique customization of particular objects. So if you did use a loop to produce your nodes and everything, then you kind of have to style them the same as well. But if you do it this way, you get a little bit more customization. But you can see that some of the nodes aren't even the same size, which is a little bit annoying because we didn't change the font size. All that we did was give this one a superscript, and this one doesn't have a superscript. So the nodes have been formatted in not the same way, which I think is kind of annoying. But we can fix this pretty easily, maybe not pretty easily, but pretty manually. So this is the same as what we've seen before, but now I've got this extra command in here, and this is just to manually center the figure once it gets too wide. Maybe I'm showing too much of the code. So yeah, that just lets you control it a little bit, or you can change the geometry of your LaTeX document, but this is the way that I normally do it. So in this example, I'm reading from here. In this example, we use two nodes. One node to produce the shape with a fixed size using this inner sep equals minimum size option. And then the other, node is to produce the text. Since the nodes format essentially independently, this means that we can adjust the text as we like without changing the size of the shape. So in this example, you should kind of think of every pair of nodes as producing one thing. So here I didn't give any text to the first one because I just want to use this one to draw the circle. And then, we give it this inner sep option to pick the size. And if we keep that consistent throughout, you can see 3.5, 3.5, 3.5, 3.5. As long as we keep that for every pair, then they all get formatted in the same size. And then I just made the text a bit larger as well, but you can see that like these coordinates always line up with these coordinates. So before we've seen that you can use one node to draw the shape and the text. Here we're using two nodes to draw, one for the shape, one for the text. So all I did was pick the spots of the different neurons and then go through and just kind of do these pair of nodes for every one of them. And yeah, I just think this looks better because we don't have the neurons around these A3s being increased in size when they don't really need to be. You can probably see that even if it was this size, you could fit this text in this neuron, but LaTeX just does things like that. Probably one thing I should have just mentioned earlier as well is that keep in mind that if you were to produce graphics for your paper, then you obviously want to turn the help lines off after. So you just, I don't know, in my opinion, you just turn them on to give you a kind of nice canvas, and then you draw your picture and then you turn them off. But you don't comment it out, you put the white here. Because if you don't, then sometimes your image will just shift, and that can be kind of annoying. So this is just me drawing all of the nodes or the neurons in the neural network, and then I just did the same thing as before, but I gave some options to the draw. But this is nice because you can still use, here I've used 2 instead of dash dash, but I'm pretty sure that it does the same thing. So in 1 to 8.1, so that's that line there. 2 is a little bit more customizable, though. You can pass other options to the draw, like in and out. Maybe I should show you. Out equals, let's say 180, in equals 0. I don't think those options work with dash dash though. So yeah, you can see that what this has done is that the line leaves this first node from like an angle of 180 degrees, and then it goes into the second node at an angle of 0. So that's like 0 degrees is the positive x direction, right? So that's what's happened here. So these options don't work with dash dash from memory. So yeah, 2 is a little bit more customizable, but I think for most purposes, you can see we've still got the options there, but it's still just doing a straight line. So yeah, if you want to customize things even more, then you could do that. But I think for most purposes, you can get away with just dash dash and then dash. I don't even know what that character's called, but these 3 here, I think they're pretty sufficient for most purposes. But yeah, you can get a bit more customized if you really want to. And yeah, I just went through and did exactly the same thing as before. But then I added these labels. So again, I've used just one node here to both draw the image and include the text. And there's nothing really special about this except maybe the align center. So that just says that the text should be aligned within the node in the middle, right? Not as if it was left justified or right justified. And I've specified this text width so that the text wraps. Whereas if I didn't, then I believe that, which one should I do it for? Where's the second? Then I think it looks kind of ugly from memory. Yeah, so I like it better when the words are stacked. So here, if you specify text width equals 2 centimeters, then that just tells you how wide can your text be. Are we happy to push forward? Is there any questions or anything? Nope. All right. Yeah, I think that centimeters is, I think the grid coordinates are 1 by 1 centimeter. I think. Maybe I should have tried it on this one actually. Oh, maybe not. Maybe they're 10 centimeters. It is definitely possible. I just don't really know how to convert between them. Yep, I believe you can just pass scale equals 2, I think. Oh, maybe it's not happy with that. Oh, it did do it. Yeah.
And then I assume that you can't rescale centimeters very easily.
Yeah, probably not. I'm pretty sure, yeah, that was actually a comment that I was going to make at some point, which was you can pass scale here as well. I might have done it later, but I'll just show you now. You can pass scale here as well. And it will like basically multiply all the coordinates, but I'm pretty sure that because I've used millimeters and centimeters and stuff, it doesn't really know what to do about it. So yeah, maybe you would be better off again, like maybe that's a better practice, but my manual approach hasn't really incorporated that. But yeah, that's a good thing to keep in mind. All right, so I'll move on to the next example. Oh, yeah, here we go. Scale equals 0.5. This scales the whole picture by whatever factor you specify, in this case 0.5, which we can see from the size of the help grid line. This doesn't scale everything though. For example, I had to manually change the font size of the labels on the neurons to footnote size. So yeah, there's another thing that maybe scale doesn't really know that much about. And the lines and the arrowhead are the same thickness. So you can see that here, even though the picture is half as big, the lines are still the same thickness when I feel like they really should have been scaled down. But obviously that's just some kind of incompatibility. So yeah, the only solution I have to this is a very manual one. So now what we're seeing for the first time is this include graphics. So in this bit of code following this bit of text, we're importing the picture of the mnist integers and trimming it by passing these options. Trim equals left, bottom, right, top, and then comma clip to the include graphics. And we also specify the width of the cropped image using this width option in the include graphics too. And know that you can use predefined variables such as 0.5 text width to scale the image to the size of the page less manually. So, if you started using columns or 2 columns instead of 1, then the width of your include picture would scale to the column text width. So I'll just show you what the original picture looks like. So you can see here that there's a whole bunch of integers from mnist there. Basically what I did was go and pick out a section of this by passing this trim. So here trim equals left, bottom, top, right. Left, bottom, top, right top. Okay, yeah. So I guess it's like from the left clockwise. So I trimmed 4.5 centimeters off the left and then 4.5 centimeters off the right and 0.7 centimeters off the bottom, and then printed that part of the image here at -8 5.5. And I gave it a width of 2 centimeters. So this trim just trims the original, with the clip, trims the original image, and then this width option says I'm going to make the trimmed image this wide. Then I drew an arrow from this to the neural net to indicate that, in multi-class classification, using the handwritten digits in the MNIST dataset and a neural network, what you do is you start with the images and you pass them to the neural network and you train the neural network. And then the idea is that afterwards, the neural network will give you some kind of multi-class label for your input. So yeah, just a basic diagram to show you guys how to use the include graphics. And it just means that you can take pictures from other places and just chuck them in as you like. There might not be anything else worth noting here, but yeah, like I said in some of the notes up there, I had to like manually scale the size of the text here because the scale 0.5 on the TikZ picture didn't deal with it. And that's pretty much it. I'm pretty sure that everything else is essentially the same. And then here are the arrows. And then, yeah, that's all pretty standard as well. I just put the line there and put the set here. I do think it's good practice to comment though, because if you didn't have this stuff and you came back and you weren't really sure what you were doing, it makes it so much easier to decode your own mental messes. And I also think it kind of makes sense to code in a kind of ordered way. So up here, I started with the left layer, then the first hidden layer, then the second hidden layer, then the third hidden layer, just because, again, it makes it easier when you go back and look at your own code to actually figure out what you did. And then this is the second last example that we've got. And in this one, we're going to draw a flowchart. So, yep, turn on the grid and then draw the start node, which is this top one up here. And then here, so I'm pretty sure I started by drawing all of the nodes first. So this is the import labeled data node. And then this is the split labeled data node, my bad. If you guys want to change that on yours, you can too. And then the testing data, validation data, training data, initialize neural network, that's this one. So you can see here that I've used the node to specify the text width and wrap the text. I think I did that maybe with most of them. And then this is the contents of that node. And here is the option. So you can see that we drew it as 50% blue, 50% white. And then this is still just more nodes. And then here, yeah. So, I mean, I'm not sure if I really need to go through this. The idea here is just we have a whole bunch of nodes and one node for each of these labels or each of these vertices in the flowchart. And all we do is we specify, not like that. We specify how we want whatever you've decided to print with this object to be formatted, and then you give it a label, and then you tell it where it needs to be, and then you tell them text you want within this shape. So it's all, I pretty much just did all of that manually, but again, it gives you a lot of customization. And then here I started drawing the lines as thick arrows to indicate the flow of the chart. So we start at the start one and go to the import data, then from the import data to the split data to the test data, the validation data, and the train data. Then I went back to the start and went to the initialize neural network node. And you can see that I didn't really have to do a whole lot for this part. The only one that I did have to manually intervene a little bit for was the one that goes from the loss condition back to the training of the neural network. So this is a flowchart that just tells you about the workflow involved with applying a neural network to some labeled data for the purposes of supervised machine learning. So at the start, you do two things. You import your labeled data, and then you split it into testing, validation, and training. But you also have to initialize your neural network. So that means choosing things like, and I'm sorry if this isn't familiar for some of you, but the point of this exercise is not to understand the information I'm telling you now, but just to get a feel for how you would tinker with your own flowcharts for your own purposes. But from the start, the second thing you do is initialize the neural network, which means choosing the number of layers, number of neurons, the activation functions, and the random initial weights. And then the first step after you've split the data and you initialize your network is to train the neural network for some epoch. So that just means update the weights in the network. And then we apply the model to the validation data and we check if some condition on the loss function is satisfied. And if it's not, then we need to go back and train more. But if it is, then we just apply the model to the testing data, which requires the testing data as well. So yeah, the only place I really had to intervene was here, so that this line from the loss condition part up to the training of the neural network part first goes out in the X direction by 1 unit so that it looks nicer. Because if I didn't have this part, then there'd just be a line that goes from here probably straight up to this thing, and we don't really want that. Or maybe it would cross over this middle part, and again, we don't really want that. But all of these other ones, to get the line going horizontally and then vertically here, I just horizontally first and then vertically. And again, horizontally and vertically, that's from here. And I think that, yeah, one nice thing about this is that most of the time you don't have to do too much work to connect labeled nodes together. But there can be some finicky parts involved in trying to always use nodes to both draw the shape and label it with text. So sometimes I'd recommend doing it with the 2 nodes, or you can use a node and a draw. I'll talk about that in a few minutes. Now we're on to the last one. So this one's pretty much just an application of some of the stuff that we did before. So we started with this big blue circle, so draw the background. And then we draw the magnetic field lines, which are these lines in here, using a couple of loops. Then we draw the particle and its spin vector. Sorry, this isn't really formatted in the same way as my other stuff was, because I just copied it from one of my old files to show you guys. Just a little bit about, all of this stuff should be pretty easy to do with TikZ. All I did was draw these 4 squares, label them with N's and S's, and then I drew some circle arcs here and here, and then filled them with gray here and here, filled them with gray. Use the loop to draw the lines. Draw a ball at the center, and you can use this shading equals ball option to, you have to have shape equals circle. I don't even think you need shape equals there, but maybe you can test that if you're interested. But just by passing shading equals ball, we get let's see if you zoom right in. It's just a nice shaded ball. You don't have to do much for it. So yeah, that's pretty much all I had to show for the examples. Just some last things was that out of interest, I thought I would just show you this. So this was something that I made for primary school kids, actually. But I did it all with TikZ and just a few loops, and it really wasn't that hard. And it's not a glorious way of making a video, but I think it's just nice because the images are high quality and all of that. So this is just a particle in a vacuum that's got this little vector associated with it called its spin. And this is just to kind of like introduce the idea of quantum computers and the quantum versions of bits versus the classical versions of bits. So this particle can serve as a quantum analog of a bit, which we call a qubit. And we encode information into the direction of this arrow. And the idea is that within this vacuum, we place a magnetic field, or we impose a magnetic field onto the particle. And then after some time, the arrow will line up with the magnetic field. And this is what we call the 0 state. So this is kind of like this is like the quantum equivalent of a binary bit just being a 0. But we also need to be able to manipulate this arrow so that we can change the information that's stored in our quantum computer. And we can do that by using a laser. And if we shine the laser for the right amount of time at the right frequency and the right color, then we can flip the arrow around and turn the 0 into a 1. But then after some time, the particle will settle back down and line up with the field again, which means that quantum information only has like a finite lifetime, because after some time, it will be disturbed again. And we only have a minimum amount of time to do our processing. So we can do something different. I'll just go through this. You don't have to understand this the content of what I'm saying, but I just thought I'd show you this because it really didn't take me that long once I had the kind of like basic code. So yeah, if rather than going all the way around, we just flip the arrow until it's halfway, then this is what we call a quantum superposition. And if we look at a quantum superposition, one of the weirdest things is that we never actually see a quantum superposition. All we see is that the arrow will randomly flick up or it will randomly flick down, and we don't really have any way of controlling exactly how. The best we can do is be aware of the probabilities of all the different outcomes. So yeah, Einstein didn't like this, God doesn't play dice, because yeah, if we did exactly the same experiment, then most scientists would agree that identical experiments should have identical outcomes for the reproducibility aspect of rigorous science. But quantum doesn't have that particular property, because previously when we looked at this superposition as saw a 0, this time we look and we see a 1. So yeah, just a nice way that you basically just do a loop that has some kind of variable, and then you can pass the loop to the coordinates of one of your draws and animate the movement of the arrow. And within that loop, you also have to have, I use something called Beamer for this. It's like the LaTeX version of PowerPoint, and you just need to put, I can't remember exactly what it's called, but it's document class Beamer or document class Beamer presentation or something like that. And then, yeah, you can just create slides. I haven't showed you that here, but just to give you an idea of the kind of things that you could do with TikZ. It's pretty simple to just write a loop, and then within that loop, you create a slide that has the variable is equal to one particular thing, and then you do that a bunch of times, and you can kind of put them together as if they are frames of a video. But that's all I had for the exercises. Yeah.
There's so many images in the PowerPoint, did it take ages to compile, or was it relatively quick?
I mean, compared to how long LaTeX documents normally take, it does probably take like 3 or 4 times as long, but it wasn't like a computational complexity issue. The only thing is that the file, I think, can become pretty big if you used a really fine increment, like, massive numbers of iterations in your loops, then probably your file size will get big. But yeah, it didn't take long to make. So yeah, I think so I have made some exercises, but I did also have these closing remarks. I won't expect, you can read through it in detail if you want, but I'm just going to say words that don't necessarily line up with these words, but I'll read this first part. In the tutorial, we've seen a few different ways of producing shapes with some text inside, so I thought I'd take a moment to give you my perspective on the different methods. So if we just use one node, which just means like this, right? We pass the draw option to the node so that it actually draws a shape around the text. And we specify a place and we give it a label. Then this is great because it's the most convenient option, but it's the least customizable one. It's really finicky to fiddle with how the shape surrounding the text is being formatted. So if you have issues with the formatting of a single node, then you can use 2 and still maintain the option to reference the node without having to actually explicitly specify the coordinates. But in my opinion, probably the easiest one is just to use a node to make the text and then just draw a shape around it. So you lose the ability to draw lines from this text to other bits of text conveniently, because the draw, when you we could label this node, but then when you put the label for that node in drawing a line or something, it's not going to know about the shape that you drew around it. So you lose the ability to conveniently line up the end point of that line with the shape that you've drawn around it. But you can get around that by just, you have the label if you choose to pass one to the node, and then you just say, we want to move from this position a little bit until the endpoint lines up with the shape that you drew. So yeah, there's basically like 3 different ways that you can go about drawing a shape with some text inside it. And I feel like in this direction is increasingly less convenient, but also increasingly customizable. So this is the most convenient, least customizable in the middle. And then this is the least convenient, but the most customizable. So yeah, that's all I had for today. We can go through, maybe I'll get you guys to have a go at doing the exercises. So if you look at, yeah, so it starts on roughly line 800. And I've just written some little directives here that your code goes here. So I want, there's 4 of them. I don't expect you, even if you don't want to stick around for this, that's fine. But I just gave you these kind of exercises if you would like to try them, and we can talk about your code and you can ask me questions and all of that. So yeah, thanks. If there's any other questions about what we already went through as well, don't be afraid to let me know. Yep, you can. So you have to use you can't really do it like from your same document, but yeah, I should have really kept it. I actually used this to produce the exercise files, but I'm pretty sure that all you need is, so you start with the document class standalone, and then you use package TikZ, and then you begin document, end document, and then in here you begin a TikZ picture. And then so I'm pretty sure is that everything I need? Use package. I think that's all you need. So now you could save this you could save this PDF and then use that as something that you could import elsewhere. So you can't directly export them, at least to my knowledge, from your big document. But for example, I could just like copy this whole TikZ picture and then paste it here, assuming I haven't used any of the other packages that I imported. And then, yeah, here I could just download this PDF. And then you've got just the picture. So again, it's pretty manual, but it is possible.